Hello everyone. So in this video, we will discuss about the data types in Java. So before going to data types in Java, we need to know what is data type and why we use this data types. So mostly in all the programming languages, we use different variables like numbers, characters, strings, etc. So while programming, how can we identify whether the variable which we are using is of type character or number or string? So it means if you are using a variable or if you are using a number, so we know that it is a number, but how program will know whether it is a number or character or string or any other symbol or something. Okay, so to identify this, we use data types. Okay, so data types usually specify the size and type of the value that can be stored in the variable. So type means a number, character, or string, or anything. Okay, so same like all other programming languages, Java also has its own data types. In Java, these data types are classified into two types. One is primitive data type and the second one is the non-primitive data types. So first we will discuss about the primitive data types. These primitive data types in Java are predefined. It means whenever we install the Java, we will get some libraries, and these primitive data types are included in that library. And we cannot create a new primitive data type. So while writing a program, if you want to try to create a new primitive data type, it is not possible. And all the primitive data types are predefined in Java. And this predefined data types will specify the just size and type of the variable. It means how much we can store and what we can store. Only this will be defined in this primitive data types, and these primitive data types won't have any additional methods. For example, if you create a variable of some data type, then we can just store the value in the data type, and using the data type we cannot perform any other operations. Okay, so that variable can be used in any other operations, but uh, by calling that variable we cannot do any operations. I mean, we cannot call any operations with the help of that variable. Okay, and these predefined or primitive data types basically are stored in the stack memory. So in Java we have heap memory and stack memory. Okay, so whenever we create a new variable of this primitive data type and gives some value, then that value will be stored in the stack memory. Okay, and based on the requirement, uh, there are 8 primitive data types in Java. So these 8 primitive data types are byte, short, int, long, float, double, char, and boolean. Okay, so these all are used for different values. I mean, if you want to store string, we will use something. If you want to store number, we will use something like that. So in this, byte, short, int, and long are used to store the whole numbers. Okay, and this float and double is used to store the fractional numbers, and char is used for characters, and boolean is used to for true or false. Okay, so here we are saying like byte, short, int, long are used for whole numbers, but what is the difference between this byte, short, int, long, and why we are using 4 data types to store whole numbers, and why we are using two data types to store the fractional numbers. Okay, why we are using is uh, these four, for example, these 4 byte, short, int, long are used to store the whole numbers. But the value that we can store in these 4 data types are different. Means byte has its own range of values that can be stored in byte data type, and short has its own range, and int has its own range. And finally, byte can be stored only less range of value than short, and short can store less value or range than int, and same way like long. So these are for used for whole numbers. So we will see what is the exact range and what can be stored in this whole data types. So in this picture, they shows the different data types and the size of each data type and the range of values that can be stored in it and some examples. Okay, so if we see here, this data type byte has its size 1 byte. 1 byte means 8 bits. It means when you define a byte data type, the memory will allocate 8 bits or 1 byte for this variable, and whatever we store, it will store in that memory only. So as here we are saying it can store of only 1 byte. So based on that 1 byte, the range that can be stored in this byte variable is minus 128 to 127. Okay, only this range we can store. And same way short is 2 bytes. So as size increased, the range of the value that can be stored are also increased. Same way hint 4 bytes and the range is this. Long 8 bytes and the range is this. Okay, so here we said byte can store only minus 128 to 127 range. So if you try to store 120, 130 or 140 in a byte, it won't take it. It will throw error. Okay. So this is this four used for whole numbers. And here next float and double. So this float and double are used for floating numbers, and float has 4 bytes and double has 8 bytes. Okay, and these are example like floating or decimal examples. Next boolean. Boolean has only size of 1 bit. 1 bit can store only either 0 or 1. So 0 means false and 1 means true. And char has 2 bytes, and it can store different type of characters like numbers 1, 2, 3, or alphabets, or any extra special characters, symbols, sorry, special symbols. So all these characters like numbers, alphabets and special characters, so that is special symbols, each one have some ASCII code. So when you try to assign this character to this variable, the actual ASCII value of that character will be stored in the this char variable. Okay, so these are the different ranges of this primitive data types. So now we will see an example of each data types. So here we have a class called primitive data types. In this there is a main method, and here I have defined different primitive data types. So first set of is this is used for whole numbers. So here I have declared a byte primitive data type. I declared a variable a, and that variable a type is byte, and I have assigned value some value, and same way short, int, long. So I have discussed based on size of this data type, the value that can be stored is increased. So if you see here, byte, short, int, the size is increased, and based on the size, the range that can be stored is increased. But why? Why this range increased when size increases? So basically, a computer or system will store the values in the memory in the binary format, either 0 or 1. So in the binary format, now for example 00 indicates 0 and 01 indicates 1, 10 indicates 2 and 11 indicates 3. Okay, so here we are using 2 bits. So by using 2 bits we can store the range from 0 to 3. Okay, so if automatically uh, 111 this indicates 7, it means when the number of bits are increasing, the value that can be stored in this memory will automatically increase, right? So that's why for each data type based on the size, the range of the value that can stored will increase. Now for byte, if you take for byte, the byte size is 1 byte here. So 1 byte means 1 byte is equal to 8 bits. It means it will be like this: 1, 2, 3, 4, 5, 6, 7, 8. So when you declare a variable a of type byte, then Java will allocate 8 bits memory for this byte. Okay, for this a variable. Now in this memory you can store 0, 0, this all 0, 0, 0, 0, 0 to uh, all ones, 8. So this range to this range we can store in this byte. Now in this 8 bits, the first bit is used to indicate positive or negative. Okay, so if it is 0, it indicates this whole calculated value will be negative value, and if first bit value is positive, then this whole calculated value will be positive. Okay, now this all zeros are now I have said the maximum value that can be stored here is 1, 2, 3, 4, 5, 6, 7. So maximum is all ones, it is a maximum value. So this all ones indicates the value when we calculate to actual number, it will be 2 power of 2 power of 7, because we are using 7 bits here. So it will be 2 power of 7. Then 2 power of 7 is equal to 128. Okay, so the maximum value that can be stored in this is 128, and by including 0 it will be 127 maximum value that can be stored. And now here 0, if it is 0, then it will be the minimum value, it will become the minimum value, because 0 indicates negative, so it will be minus 128. And if it is positive value, then this value will be positive and the maximum value will be 127. Okay, like this. So like this it defines the range of a particular value. So that's why byte has 8 bits. So based on 8 bits, the range is between minus 128 to 127. And same way short. So for short we are using 2 bytes. 2 bytes means 16 bits. 16 bits means like this. 16 bits means like this. So when we create a variable b of type short, it will allocate 16 bits memory to this variable b. So if when this size allocation memory got increased, automatically the range of value that can be stored in this will be increased, right? So that's why the automatically the range is increased. Same way for int and long also the range is increased. Okay, now these are different data types used to hold these four are for whole numbers. Now in this byte we said we can store only from minus 128 to 127. But what if we try to store 140 in this? So 140 means when this 140 is converted into binary format, the number of bits used will be approximately 8 or 9. Okay, but the size of this byte is only of 8. Sorry, the byte size will be only 8, but 140 it will use 9 more than 8. Okay, it means 9 or 10. So the see 140, for example, if you see, uh, so this is the memory which is allocated for byte, and if we convert this 140, for example, if that value is like this. Okay, so for example, if this is a value of 140, now this 140 cannot be fitted into this byte, right? Okay, so if we fit this into this will be lost, and this value will be changed to different value, right? So that's why when you try to assign a value that is out of range, then automatically it will give the error. So here what error it is giving? Cannot convert into to byte. So it means the value which you are using here is of range int, and you are trying to fit that into a byte, and it is not possible. That's why it is giving an error. Okay, so if you based on range, we will use this data types. Now for last one long, the maximum value is this one. So what happens if I add, if I want to store the value which is greater than this value? So we will try that. So here I'm trying to add, I created a new variable of type long, and I tried to add a value which is greater than the maximum value that can be stored in the long. So automatically it will give the error, and the error will be out of range. This value is of type int is out of range. Okay, it means in Java we cannot store we can store the value more than that of the highest long value. So the highest value that can be stored in Java is this one, this integer or whole number. Okay, and next these two are used for fractional. Now I have declared double, and this is example for double, and this is float, and float is this one. So save like this. When we declare this double and float, the automatically double means 8 bytes, float means 4 bytes. Memory will be allocated for this H and F. Now here, if you observe, I have added F here, but for double I haven't added anything here, but for float I have added F. So why this have added? What happens if we remove that? So if we remove that, it is giving error. Okay, so why it is giving error? Cannot convert from double to float. It is saying we cannot convert from double to float, but here the value which we are given is in range of float only. So float has 4 bytes. Okay, 4 bytes, but when this converted into this binary format, it will be it won't occupy more than 4 bytes. But why this converter is giving? So basically in Java, when you declare a fractional number, automatically it will be considered as a double. Yes, so now 645.321, when we assign this to G, Java will consider that this is a double value. Okay, but we know that this size is very less than the 4 bytes, and that can be fit into float, but program don't know whether the size is less or more. It only considers that if any fractional value, it is a double. Double means of size 8, and it is thinking that you are trying to assign a value of 8 bytes into a 4 bytes. Okay, and automatically it will not work, right? So when you assign a 8 bytes value to 4 bytes, it won't work. So that's why it is giving a conversion error. So that's why we are adding f at the end. It means we are telling the program that this is of this can be fitted into the float by providing the f at the end. So with this, uh, float memory will be allocated. It means 4 bytes will be allocated, and this value will be stored in this f allocated memory. Okay, so this is fractional. And next is char. So char is used to store the characters or special symbols. Now, same way, character size is 2 bytes. So, as I said, all the characters like numbers 1, 2, 3, and alphabets and special characters, all these have ASCII value. It means A alphabet A will have some ASCII value, and B will have some ASCII value. Okay. Now, when I try to assign char I is equal to 2, it will get the ASCII value of this 2, and that ASCII value will be again converted into binary format and will be stored in the memory allocated for this I variable. Okay. So this is how this works. And next is boolean. So boolean has memory of only 1 bit. 1 bit means it can store only either 0 or 1. So 0 means false and 1 means true. Okay, so these are the different primitive data types that we use in Java. And next is non-primitive data types. Okay, so we discussed primitive data types. So primitive data types are predefined in Java, but these non-primitive data types are not predefined. It means programmer can define any number of non-primitive data types. Means while coding, we can create our own data types that are called as a non-primitive data types. So non-primitive data types are also called as reference types because uh, when we create a non-primitive data type, the non-primitive data type will the variable will store the reference of the object. So we will see with example after explanation. So why we are saying this as a reference type? So when a new non-primitive data type is created, its actual value is stored in the heap memory. Okay, so if you remember, non-primitive data types value will be stored in the stack memory. Sorry, primitive data types value will be stored in the stack memory, but this non-primitive data type value will be stored in the heap memory, and the reference or address of the object are is stored in the this non-primitive data type variable. It means non-primitive data type variable will contain the address or reference of the actual object which is stored in the heap memory. So that's why these are called as the reference variables or reference data type. So same way we'll see one example. If you see here, I have created a class student, and the student has ID, name, address, and Indian, whether he is Indian or not. So here I am trying to store some value. Okay, so what is data type? It has some value and size. So here I am trying to store some value. So this can be called as a data type, and this data type is created by programmer. Okay, so this is not a predefined. So user created this. Okay, so this is called as a non-primitive data type. Now, when you want to assign some values to this variables, we need to create object for this, right? So if you see, we need to create object for the student class. Now When I create this object or when this executes this line, it will create a object of the student class in the heap memory. Uh, in the heap memory at some particular location it will create object. Now the address of that object will be stored in the student variable. Okay, it means the student variable is of type non-primitive data type, and the student variable will contain the address or reference of the object that is created in the heap memory. Okay, that's why these non-primitive data types are also called as the reference variables or reference data types. Okay. So if you want to add a value or assign a value to these data types, these variables, we will create object and we will use like this. So std dot address, we are assigning some value. Okay. Now we will see difference. What is the difference between this primitive data type and non-primitive data type? So primitive data types are predefined and non-primitive data types are not a predefined. So here you see this byte, short, long, int, this all we didn't created it anywhere. Directly we got it when the Java is installed. So these primitive data types are called as predefined. And the student here it is a non-primitive data type, and this one we didn't got when Java is installed. We have created a new class and we are using it. So that's why these non-primitive data types are not a predefined. And this primitive data types contains some value, and non-primitive data type can contain null value. So what is this meaning? So here if you take this example byte a equal to 0, I didn't initialize any value here, just I declared a variable a of byte. Now here I am trying to use that variable a. Now it will give an error. It is saying that local variable may not have been initialized. It is right because I have declared but I haven't initialized anything. So it is saying that you should not use that way, you must be initialize some value. So when I do initialize, it will have some value, right? So it contains some value. So without this, it won't be available in the code. That's why we are saying it contains some value. And same way here, I can say student std is equal to null. Null means nothing, no value, and I can use it anywhere. So it can also contain the null value. And here saying size is fixed and size is not fixed, because we already discussed this byte, short, int, long have fixed sizes, 1 byte, 2 byte, 4 byte, 8 bytes. Okay, so that's why predefined primitive data types are called size fixed. And here student, in the student it is a object, and in this object contains different data types, right? So this int has fixed memory, this has fixed memory, but combiningly we don't know how many variables we will create in the student object. So we don't have any idea, there is no fixed size that can be used for this student objects. That's why here size is not fixed, here size is fixed. And this will store only one type, this will store multiple types. So we have seen byte will store only whole numbers, float will store only fractional, and char will store only characters. But here our student object can store multiple types. If you see here, this object contains different types, int, string, boolean, different types it can store. That's why it store multiple types, stores only one type. Here it don't have methods. Non-primitive can have additional methods. So uh, this byte, if you see byte, this byte. So this byte is a primitive primitive data type. So now I am trying to use something or call any operation using this a. If I do that, it is saying no default proposals. It means There are no methods available in this primitive data type, right? So as I said, we can use this A in other operations, but we cannot call any operation using this A, right? But when it comes to non-primitive data types, we can create new methods in this non-primitive data type like this, and that can be used by that can be called, this display method can be called by using this non-primitive data type. So I am saying std.display. So we can call using non-primitive data types. It means it has some additional, we can create some additional methods in that. Okay. So these are the different types of data types and difference between primitive data type and non-primitive data type. Okay. Thank you.